All right, so let's take this system, for example. 3x plus 4y equals 18. And then maybe 6x plus 8y equals 18. All right. So we got a what size matrix would we put this into? How many rows are there? 2. So 3, 4, 18, 6, 8, 18. Let's say 2 by 3. 2 by 3 matrix. Okay. 2 by 3 matrix, and then we're going to use what little shortcut thing? Calculator RREF, reduced row echelon form is what we're going to try to get the calculator to do. Let's see what this one does. Second matrix, edit 2 by 3, 3, 4, 18, 6, 8, 18. Second quit, go back to there, and I'm going back to matrix again, go to math, and go to RREF, and then tell it which matrix to do that with. Matrix A. Now, hit math, enter, just so it looks a little better, a little smaller. We get this matrix. 1, 4 over 3, 0, 0, 1. Excuse me. 0, 0, 1. All right. Now, what does this tell us? Remember what the first row told us? This 1 right here represented 1 what? 1x. But then there's 4/3 here. That's 4/3 what? And that equals 0. What does the second row tell us? 0 x's, 0 y's is equal to, how can 0 x's and 0 y's add up to be 1? Can they? No, it's impossible, right? 0 plus 0, no matter what x and y are, 0 plus 0 is still what? 0. Does 0 ever equal 1? No. So this would be an example of one that has what kind of solution? No solution. That bottom row is going to tell the tale whether you've got no solution or infinitely many solutions, okay? Or one solution. If that bottom row has the columns here are zeros, and then something else on the end, then you know it's no solution, okay? All zeros and something else on the end. Doesn't necessarily have to be a 1. It could be a 7 or anything, as long as it's not 0. Then that tells you that it's no solution. The bottom row, after you do RREF, it's going to tell you that. Okay. If it has a solution, remember we're going to have 1, 0, and then a number, and then 0, 1, and a number. That's what we saw yesterday. Okay. So let's look at another system. We'll stick with 2 by 3 for just a minute, and then we'll get to 3 by 4. 4x minus 3y equals 10. Negative 6y plus 8x equals 20. That's our system. Tried to put a little spin on this one here, just to keep you honest. What spin did I put on it? I moved x and y in the second one, right? How do they need to be? Yeah, they just got to be in the same. They got to be in the same column. So your x's got to be first, then your y's, and then the numbers. So be careful of that when you're looking at these. So when I rewrite my matrix, I got 4, negative 3, 10, and then what should the second row be? Yeah. So rearranging that to 8x minus 6y equals 20. That's how I got there. Just swapping the order so that it's x, y number. Okay. Make sure of that because they like to just, it's a real simple thing, but they like to throw it in there, and if you're in a hurry, you don't see it and you mess things up. Okay. All right, then throw our REF at that. Second matrix, edit, 2 by 3, and then we have 3, nope, 4, 4, negative 3, 10, 8, negative 6. Okay, and then RREF to that. All right. We'll swap it over to, again, the fractions. 1, negative 3/4, 5/2, 0, 0, 0. Again, look at that bottom row. 0 x's, 0 y's equals 0. Does 0 always equal 0? Yes. So this would be an example of one that is what? Infinitely many solutions. Infinitely many solutions there because we had zeros all across the bottom. So we can abbreviate that. Okay. All right. Now, 2 by 3 systems. We've seen them yesterday. We saw with one solution, and that's where you're going to have a 1, a 0, and a number, 0, 1, and a number. We saw no solution with example A. That's where you had 0, 0, and then a number in the bottom row. And here, 3 0 or all zeros in the bottom row is infinite many solutions. You do RREF with the matrix. Okay. If you solve that with substitution or elimination, you should get the same result. Okay, so that doesn't change that sort of thing. All right, let's look at a 3 by 4 system with 4x minus y plus 3z is 13, x plus y plus z is 2, and x plus 3y minus 2z equals negative 17. Everything in the right order. We got x, y, then z. So first column is x's, second column y's, third column is z's, fourth column is what those equations are equal to. Make sure it's in that order. If there happen to be a piece missing, it's more likely that with a 3 variable system that there might be an equation that maybe one of them doesn't have a y or something like that. That's more likely with the 3 variable equations. If one of those is missing, what goes in its place in the matrix? 0. So be just mindful of that if there is a missing variable in one of the equations, it's 0 for that variable when you go to your matrix. So our matrix should be what size? 3 by 4. 3 variables, and then 4 columns. 3 rows, 4 columns. So 4, negative 1, 3, 13, 1, 1, 1, 2, and then 1, 3, negative 2, negative 17. That's the matrix we want to enter into our calculator. Three by 4, 4, negative 1, 3, 13, 1, 2, 17. Be careful, especially on these that you're getting all the signs right. That's one of the things we had problems with when we were solving three variable systems by hand, with the elimination and substitution methods, a lot of times we just miscopy something and it would be causing things not to work the right way. So be careful of that. All right. So there's our matrix. We're going to math, RREF, math, RREF, and then select that matrix. And get it out there. 1, 0, 0, negative 1. 0, 1, 0, negative 2, 0, 0, 1, 5. Tells us this is X, this is Y, this is Z. How do we write our answers? As an ordered triple. Negative 1, negative 2. Same story for no solution or infinitely many solutions. You look at the bottom row. If the bottom row after you do RREF is 0, 0, 0, then a number, what is it? No solution. If it's 0, 0, 0, 0, that's an infinitely many solution.
Where is RREF in the math menu?
You go second matrix and then go over to the middle column there. And then it's toward the bottom. So I always just press the up arrow. It gets there quicker. Okay. Did you find it? Yeah. Second, and then X inverse to go to the matrix menu, where you would go to put your matrix in. And that middle column, press the right arrow key to get to that middle column where it says math. It should be down that list. I think choice B. Bless you. All right. Let's look at one other thing. Inverse matrices, okay? Vertical. And we talked about determinant yesterday. Invertible matrices have a non-zero determinant, okay? Meaning the determinant of that matrix is not zero. It's anything other than zero. Doesn't matter what it is, it's just as long as it's not zero. That means that matrix is invertible, okay? And invertible, if we're finding a determinant to decide if something's invertible, what kind of matrices can we find the determinant of? Square ones, okay? So if we're going to find an inverse, it's got to be what kind of matrix? Square, okay? So when we find an inverse matrices, we're talking about doing all that with square matrices. So we're going to find the inverse. And again, this is a graphing calculator operation. Let's say we had a 2 by 2 matrix, something like this, 4, negative 7, 6, 10. Is that invertible before we even try to find it? How do we find the determinant of a 2 by 2? Without the calculator. Yeah, just cross multiply. 4 times 10 is 40. Negative 7 and times 6 would be negative 42. 40 minus negative 2, is that 0? No, doesn't matter what it is as long as it's not 0. Okay, so that means this is invertible. Okay, so if we're going to find the inverse, let's just name that A, because we're going to put it in our calculator as A. And then when we're finding that, what we're finding, the notation for inverse is like a little -1 exponent. It's A inverse is how that's read. So to find A inverse, or the inverse of a matrix, One way to do it is with row operations, and it takes a good while to do that. And what you end up doing is you take an identity matrix and put it beside it, and then you do row operations until this one turns into the identity matrix, and whatever the other one turns into, that's your inverse. Takes a while to do it that way. It's not fun. So the easiest thing to do, though, is just take your calculator, put that matrix in there. This is a 2 by 2. The number's right, 4, -7. And then 6, 10. All right. They can quit. And then go grab the name of the matrix. We put it in, I put mine in matrix A. And then there's an inverse button on your calculator. It's this one right here. It's x to the -1 power. That's the inverse button. Math. Enter to make it look a little better. And there we have the inverse matrix of that. Is it pretty? No. 5/41, 7/82, 3/40, -3/41, and 2/41. Make sure I typed in that matrix right because I'm getting a little funny, some funny looks. 4, -7, 16. 4, -7, 16. Yeah, that's right. Inverse, and one of the ways that you can verify that that's correct is to multiply those two together. So if I take matrix A times this inverse, I'll get what's called the identity matrix together. So if I do that, if I take this matrix second answer times the matrix that I put in, matrix A. This is what I mean by identity matrix, the ones and zeros. So it's when you think about regular numbers, we think about the inverse, the multiplicative inverse of the number 3. What's the multiplicative inverse of the number 3? Multiplicative inverse is a big word that just means what? For the number 3, the inverse is the reciprocal, 1/3. What happens if I multiply 3 times 1/3? I get 1, okay? Here, if I multiply A times A inverse, I get the matrix equivalent of the number 1, which is 1, 0, 0, 1, because they're 2 by 2. If they're 3 by 3s, it's 1, 0, 0, 0, 1, 0, 0, 0, 1. That's the matrix equivalent of the number 1, right? Multiplicative inverse, that's what we're finding for matrices when we do this inverse stuff, is finding the multiplicative inverse. And it only happens again when the determinant is not what? 0, okay? So if you had a 3 by 3, make one up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretty easy one to make up. And we'll call that matrix A. And we want to find A inverse. That one's easy to remember. That's why I picked it. I got a 3 by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm grabbing that matrix and just hitting the inverse. Uh-oh. Wonder how come. What could it be? Determinant, matrix A. Oh man, isn't that weird? Yes. Most things I do are on purpose. I stumble across some good things every now and then, but most of the things I do on purpose. Isn't that cool how that matrix works? Just the first 9 integers there, if you put them in a matrix in order like that, that it's does not exist. Determinant of A equals 0. It can't be done. Okay. So you really, if you're using the graphic calculator, you can't screw it up. It's going to give you an error if it doesn't work. All you've got to do is go back and check, make sure you put everything in the right way. If you put everything in the right way and it still gives you an error when you try to find the inverse, then you know, oh, the determinant must be 0 for that thing, and I'm done. Are you? I'm glad you're done. I'm glad you got that text message sent. Jeez. I'm done too.